Okay, thank you everybody for showing up for the Soil Basics and Interpreting Georgia's Soil Test Reports program webinar in the Garden series, which are my virtual webinars that I host twice a month, usually on Thursdays every other week, and then I've added in a lunch and learn in between on a Tuesday. And these are could be anything. There might be a little bit of geology in there. There might be a little horticulture in what I teach. Um, Sometimes nuisance wildlife, sometimes other interesting tidbits. I did zombie insects one time, but everything qualifies as Master Gardener continuing education credits. And if you just like to learn, it's a good way to kind of get a different perspective on stuff. I try to really take a dive into the history of whatever it is so that you learn a little bit of that and that you can learn about whatever the subject is so that you can come away feeling like you haven't completely wasted your evening, which hopefully you won't fall asleep on. So I do record my presentations, and they are available after, usually the week or so after, on our Metro Master Gardener YouTube channel. That will, I'll have a link with a QR code and that kind of thing at the end of the presentation, along with my email. If you have any questions, you can reach out to me. I am happy to provide the slide deck if you want that. I do not send that out to everybody. A little bit too hard to do that. I do have some registered folks, but the link's posted in several different locations, and so I don't necessarily know who I have. So if you would like it, grab my email address off that last slide and send me an email, and I am happy to share. So I have muted everybody, and I think I have it fixed so that you cannot unmute yourself. We've had a couple instances in the last couple programs where people were unaware that they were unmuted, and it was a little disruptive. So I figured it was probably easier to set the control so that nobody could unmute themselves. So if you have a question that comes up as we're going through, please drop that in the chat box, and I will get to that at the end of the program. All righty, let's go ahead and get started. So soil is the basis of everything. If you are a gardener or want to be gardener or know somebody that's a gardener, you have to know a little bit about soil, because it's really almost impossible to have good plants or trees or bushes or whatever if you don't understand about the soil. What do I mean about that? Well, you've got to know what a plant needs. So we're going to go into that nutrient wise. The different types of soil, you got to know about that. There's a lot of different things that you really need to know about in order to understand how your plants are going to do better. So why should you care? Well, right here, you want to get better crops, be that fruit or vegetables. Maybe you just generally want to improve the soil. I don't know. Some people like black soil versus the mineral kind of iron heavy soil that we have here. Maybe you want to be sustainable. You want to make sure that whatever you have growing around your land, you don't have to do a whole lot to it in the way of adding synthetic fertilizer or something. Maybe you really want to show off your lawn skills and you want everybody to look at your grass and be jealous. Maybe you want to have healthy livestock. Honestly, if you have cows, if you have horses, or even chickens, it's really important that you understand what's in your soil and try to have better soil so that you can grow whatever you need to as forage for your animals. So what are soil basics? Okay, so we're going to learn what's in the soil. We're going to learn a little bit about how it's formed. We're going to figure out how it's classified. We're going to learn about soil textures, and we're going to learn why pore space is important in soils. So I know there's a lot of master gardeners on this particular program that I have. And there's a few new ones that are in training right now that are in my class. And so this is just going to be a review. You've seen it several times now, but for some of those that have been around the block for a while, this will be a little bit of a review. And some of you may learn something new. Also, we'll learn about soil structures. We'll learn what causes a lack of fertility in the soil, like why are things not growing as you think they should. We're going to learn the soil nutrients, and we're going to take a kind of a shallow dive into the chemistry pool, and we're going to learn a little bit about pH, because there's a lot about chemistry that goes along with soils. So if you have hopes of being an organic producer, you really need to understand the chemistries of the soil and the pH and how everything interacts. But don't worry, it's not going to get too crazy. I promise. Okay, so you're going to learn a little bit about Georgia geology, because we have a lot of transplants, and we're going to learn a little bit about chemistry and the soil, nutrient deficiencies, symptoms. Again, I mentioned organics. You have to learn what that looks like so you know how to treat it, how to properly collect a soil sample if you want to come down to Extension and have us do an S1 soil test, which is just a standard fertility test. We do a lot more. So if you have other concerns or want to learn a little bit more about your soil, we have a whole host of soil tests that we can do. We'll teach you how to read that test, that S1 soil test, and how to keep that soil healthy. So first of all, let's start out with what's in your soil. So you can see here in this pie chart, pretty simple to look at. It's about 47% mineral. So the proper way to refer to good old Georgia soil, if you were to walk out there and take a shovel and just get a big old scoop out of your yard, is mineral soil. And that is different than what you can get out of a bag at the big box stores. It may say raised bed soil. It may say topsoil, but it's not actually topsoil. Mineral soil is the actual soil that comes out of the ground that hasn't had any amendments added to it. So of that, you're going to get 25% air, and that's going to be in those little pore spaces in there. About 25% water, hopefully, although last summer we had some problems with that. It was a little dry. And then you're going to have about 3% organic matter. Well, what's in organic matter? That's a good question. Look over there at the little chart to the left. So you're going to have about 200 billion bacteria, 20 million protozoas, about 100,000 meters worth of fungi, and that's going to be all those little roots that they're going to spread out there, mycelium. About 100,000 nematodes, little worms, you'll see some pictures, and about 50,000 arthropods. So that's a lot of stuff, organic stuff, that lives in about 1 cup of soil. Missed that. So basically, you've learned the soil is going to be very alive with all sorts of stuff, and that can influence the health of the soil. Just as kind of an aside, because it's a neat little factoid, after the Chernobyl incident, still to this day, you will not see much of the forest litter as the trees lose their leaves. Usually you'll have fungi, bacteria, earthworms, other little decomposing insects and arthropods breaking that litter down. But because of that Chernobyl disaster and all the radiation, a lot of those are absent. So it can take a lot longer for that forest litter to decompose, because a lot of those animals and bacterium and all of that stuff, they're not there anymore because of the radiation. So a good, healthy soil column is going to have all of those critters living in there, and that's how we want it. That's a good thing. So soil biota. We're going to start kind of go through each of these, not spend a ton of time on there, but you'll learn a little bit. So bacteria, they're going to feed on soil organisms and help decompose that organic matter. So if you have a compost bin, these guys are in there, they're breaking stuff down, they're using nutrients, and they're going to help keep additional nutrients in the root zone. So they're going to help enhance that soil structure. And the better bacteria, the good guys, those are going to compete with the bad ones that you don't want there, the things that can make you sick. They're also going to help filter and degrade pollutants in the soil. As an aside, I will have a new presentation that I've created on soil remediation. I know that doesn't sound very interesting, but it's actually really interesting because bacteria, fungi, plants, certain things can help break down toxic elements and other things that maybe we don't want in the soil. And so there are a whole host of those out there that can help remediate or fix the soil after there's been some kind of a toxic spill, or maybe you've got too much arsenic or other things in there. So be watching for that. That'll be an interesting one. Protozoans, these guys eat those bacteria. So the bacterium are going to have a lot of nitrogen, and those protozoans want that. So if they do that and they go through that particular life cycle, ammonium, which is NH4, is going to be released to the plants. So here's where we're going to inject a little bit of chemistry. Just be looking at that's a compound. So you've got nitrogen and hydrogen, 4 hydrogen molecules. So again, don't need to get too excited about that, but if you're going organic, just be familiarizing yourself with compounds because those are important in organics. So protozoans are going to prevent some of those pathogens, or the bad guys, from establishing on plants. And they're also good for nematodes. So we're kind of starting really, really tiny, and then we're going to work our way up to the bigger decomposers and the bigger bugs and things that are in the soil. Fungi, or the fungis. So these guys decompose complex carbon compounds. What is that? A chunk of wood, just for lack of, anything else. It sounds really fancy, but it's just basically big chunks of organic matter. So they're going to break those down. Their little mycelium are going to get in there. They're going to kind of tear that apart and make it into smaller particles that then the other smaller decomposers can work on. So they're going to help keep those nutrients in the soil. For those of you that know, you probably know mycorrhiza. That's a fungus, and that has kind of a commensal or good relationship in the soil. So like if you go buy Soil 3, those big yellow bags, those are going to have that as an addition to the soil that you're buying, the soilless mixture. And that helps the plant roots get additional moisture and nutrients and things. So it's helping the plant. So that's a good fungi. But they're going to help bind soil particles into aggregates, meaning larger chunks. And they're going to compete also with plant pathogens. So they're good, and they keep the bad guys away. And as I mentioned before, they can help decompose certain types of pollution. There are certain types of fungi and bacteria that can work on petroleum products and break those down. So lots of good reasons to have these guys in the soil. Nematodes, I don't like worms personally. They're very small worms, like very small worms. So most species are beneficial, and they're actually feeding on the bacteria, the fungi, and other nematodes. There are some that are bad. Sometimes you get root knot nematodes. If you're in agriculture, sometimes you can have problems with that. Corn, soybeans, and some other types of crops. But if you have the good ones around, they can help keep the bad ones from becoming an issue. So they're going to help distribute the bacteria and the fungi throughout that soil because they move around. So similar to what an earthworm does, it's just a larger scale on an earthworm. They're going to move through the soil, and they're going to help distribute the other stuff. The predatory nematodes, those are the good guys, and they can eat those root feeding or the root knot nematodes. So the good guys keep the bad guys in check. So some of them are good. Arthropods, bugs. So these are insects, spiders, mites, and other things that are going to crawl through there, and they're going to create tunnels, burrows, basically structure, and they're going to poop. And so that poop can get fed on by bacterium, and they help by controlling more of those disease-causing organisms. And because they have that poop that they're leaving behind, that can actually enhance microbial activity, or the bacteria, they're going to feed on that. And then thus the whole life cycle. So they're going to enhance that decomposition by going in there, and those beetles are going to chew and shred, kind of depending on what mouth parts they are, depending on the type of bug they are. And they're going to help mix all of that organic matter and the other stuff together into that soil and make that a healthier soil. So basically, that whole food web, these guys are just part of it. Earthworms. So I mentioned nematodes, which are tiny, tiny little worms. These guys, of course, are bigger, and they're going to enhance that decomposition because they're really moving through that soil. And then, of course, they're leaving their castings behind. And if you know anything about vermicomposting, you know that worm poop is black gold. That's expensive stuff. I mean, you can get like a tiny little sack of that on Amazon for 35 bucks. So if you have your own worms, you can collect that, make worm tea. There's a whole lot of stuff. I've got a good presentation on vermicomposting. But worms are good. There's different types, of course. Some of them live in the entire soil column. Some of them live just on the top. Some of them migrate between the two areas. It just really depends on the type of worm that you have. All right, how's soil formed? Well, that's a good question. Most of you are probably aware there's a soil horizon, and there's different labels, if you will, to that soil horizon. So basically, you're going to start out with some kind of usually a rocky material. That's going to be your parent material. And then geologic time, we've all heard that, but that's a very long, long time. And climate, so rain, freezing temperatures, sunshine, UV, all of that stuff is going to work on that parent material, plus a little bit of those biological organisms are kind of in there, and topography, so hills and valleys and rivers and all of that stuff. They all work together to make that topsoil, or that soil, mineral soil, that we all need and love. So what kind of soil? It's really going to depend on the parent material. So if you've been in the Midwest, you'll know that that's kind of a glacial loess up there. It's very black and it's very rich, very gorgeous looking soil. It will grow a dead stick. I swear it will regenerate a dead stick. Whereas down here, we have a very iron rich soil, lots of clay. It's very dense, very heavy. It's not a bad soil. It just needs a little bit of help to make it a little bit nicer for some of the plants that we want to put in it. But it's really going to help. So what kind of type you have, and also the type of vegetation that's growing there, and how the root system all breaks that down, and the climate that you have, the amount of rain, heat, cold, all of that stuff, that's all going to have a factor in on what kind of soil you have, in addition to how much topsoil. So topsoil is going to be that top 1 inch or 2 inches of soil that the plants need, that the plants grow into. So here in Georgia, in and around this area, we don't have a lot of topsoil. We just don't. We weren't subject to glaciation, so we don't get that really rich, gorgeous looking topsoil that they have up in the Midwest, where you have a lot of the corn belt. But we do have, decent soil. It's just got a lot of clay in it. So again, how's it formed? Topography, or the slope of the land. What you see there are just some contour lines. Without getting too fancy, that contour line, the closer they are together, the steeper that is. So you can see there's a 300 there. That would be 300 feet. And then you've got the 200 foot. That's basically a little knoll or a hill. Not little, there's a difference of 100 feet there. But the closer those contour lines are, the steeper it's going to be. So the steeper it is, the more erosion you're going to get. Maybe the higher up it is, the more UV radiation you're going to get, that kind of stuff. So under prairie grasses, just as an FYI, if you want to know some trivia, it can take about 1,000 years to form 1 inch of topsoil. So if we all remember the Dust Bowl, that was before farmers really understood how important it was to protect that soil. 1,000 years is a long time. And so a lot of that blew away, and we all know what happened in that scenario. So under trees, just as a comparison, it can take about 10,000 years to form 1 inch of topsoil. So that's a long time. So we really, really, really want to preserve what we have. And here, because I call them gully washers. We get the gully washers, just like last night really wasn't a gully washer. I think we got about 6 inches at my house. It was very steady over the course of about 24 hours. But in the summertime, with some of those rainstorms that we get, we might get 2 inches in 30 minutes. And that's going to run off and cause some problems that causes erosion. So it is important that we protect the soil that we have. So we don't want to leave bare soil because we don't have a lot of topsoil. And we have, clay, which is very small in particles and can wash away easily. So just beware that we do want to protect our bare soil here. Okay, so how is soil classified? So soil classification, again, I mentioned, is going to depend on that parent material. This is just your little geology lesson for the day. So sedimentary rock forms slightly differently than metamorphic. You don't really need to know what sedimentary or metamorphic is. There's no quiz later. Limestone-based soils are going to be usually more fertile than granite-based soils. So can you guess what we have here? We have granite-based soils. And what do you have up in Kentucky, Tennessee, and on up? Limestone-based soils. So here's just a couple that you can look at. So conglomerates, that's going to be where you have a lot of different rocks that are kind of stuck together. You can see that there's a couple different varieties, sandstones. A lot of people will use those as nice, pretty flagstones in their yard and their hardscape. Shales, there's oil shale. You can get and compress that under a lot of pressure, and you can get oil out of that. Also, you can get fossils. So if you like to go fossil hunting, you can go up in the very far northwestern part of our state. That's a slightly different geologic area than what we're in here, and on into Alabama, and there's a lot of fossils up there. And then there's mudstone, and there's all sorts of others, but there's just some examples. So soils are kind of depend on where they're located. So topography or the slope of the land, river drainage systems, proximity to large bodies of water, mountains, things like that. So depending on it's usually down to water. Water is going to kind of you'll get that erosion, the soils will settle out, you'll get silts and sediments and things like that to mix, and that's where a lot of those nutrients are. So geologic regions of Georgia, not going to spend a ton of time, but it's interesting. So if you're somewhat new to the state, or you just have never delved into what makes Georgia, Georgia, this is kind of a real quick snapshot of that. So you have the green area here, the lighter green area where the star is. That's Gwinnett County. That's where we are. That's the Piedmont region. Okay. And then if you have that yellow squiggly line, that's called the fall line. And basically that is the boundary of where the inland sea came up so long ago, eons ago. And that pinkish, kind of tannish area below, those are all going to be coastal plain, and the soil down there is much sandier than it is up where we are. Where we are, in that light green, it's very, very heavy clay. Not to say that there isn't agriculture that happens there, but the soil types are vastly different than what you'll find below the fall line. And then if you get up into the mountains, I mentioned that if you go up into the far northwestern part of the state, that is a different geologic composition than what we have down here. So you see southwestern Appalachia Appalachia, and you have some of that ridge and valley. You'll actually find fossils up there. We don't have really those here. You will get shark's teeth and some other stuff down in the coastal plain, but we just don't have very many. If we do, they're very, very tiny and not really anything to speak of. But if you go up there in the very far northwestern part of the state, you'll actually find some shale and some other interesting fossils. And then, of course, up in the northeastern part, that's the Blue Ridge, and that is different. Just as an aside, if you haven't lived here terribly long, you might not have experienced any earthquakes, but we do get them from time to time. And they're actually the epicenter of a lot of them is up in North Carolina. None of them are big. They're all in the fours generally, which makes you scratch your head and go, well, Lisa, why am I feeling such a tiny little earthquake all the way here in the Atlanta metro area? Well, that's a good question. It's because there is a very large dome of rock that is the same between here and all the way into South Carolina. And so when you get a four, if you know anything about waves and how they travel, this particular type of rock of this geologic area basically allows those waves to attenuate. There's the word of the day. Just basically continuing on until you feel them. So if you wait around long enough, or maybe you're awake during that time, we usually get 2 or 3 a year, and that it'll shake the house. But that's just kind of an interesting bit of trivia. So here's some major river drainages of Georgia. Not a lot to see there, except otherwise, just in Gwinnett County where we are, you can see we actually have 3 different river drainages. There's Appalachia, well, you've got the Ocmulgee, you've got the Chattahoochee, which is right there it's kind of the boundary of Gwinnett into Fulton and DeKalb, and then you've got the Oconee. And so we're lucky in that we have multiple river drainages. So we have options for water, though we get most of the water from Lake Lanier. But it's interesting. Georgia actually doesn't have a lot of rivers to speak of that can provide water. So the Chattahoochee right now is probably, of all of them, one of the biggest. Most of the water that comes from the southern part of the state come from deep water aquifers. So not from surface waters, but actually deep down in underground. So here's the soil horizon. I keep referring to that. You have the O horizon, which that's the leaf litter and other junk that all those little decomposers, the fungi, the bacteria, the bugs, all of that stuff, that's what they work on. And then you have the topsoil, which is the A horizon. And then you have the E horizon. That's kind of the leaching layer, or the area that's in between the subsoil or the area that gets down where it's a little rockier and harder, and that topsoil, or the lighter stuff that you're going to actually plant in. And then you move down into the B and the C, that's going to be your harder subsoil. So I kind of joke a lot. We have a lot of developers building in Gwinnett County, and they like to scrape off that topsoil and they bank it. And a lot of them, the ones that are really trying to pinch their pennies, will then sell said topsoil, and then they'll just lay sod over the top of that subsoil and the weathered parent material. Is that going to grow grass? No. So we'll start getting phone calls from people midsummer going, why is my grass dying? Well, it's because you barely have any topsoil on there and you're not watering it enough. So then they have to basically rip all that sod off if they're going to do it the right way, come back with some topsoil to spread on there, and then lay sod back down again. It's a racket. So the relationship between sand, silt, and clay. So this is basically the basis of it all. So to understand the types of soil that we have, you have to understand kind of the mix of these things. So most people would understand that if you picked up a handful of sand, it would just kind of drain through your fingers. Those particles are actually pretty large. They drain really well. So like down in Florida, for instance, or in the southern part of the state where the soils are pretty sandy, it'll drain really quickly. Whereas here, just as another bit of trivia, if you want to line a pond, if you want a pond here, you line it with clay, which is what we predominantly have in our soil. Why? Well, look at it. You have tiny little particles that fit together almost like a brick wall. So those will fit together and they'll seal that pond. So that's why when you go out there and you're checking to see if you can, like, let's say you built a house and you were doing a perk test to see for a septic system, or maybe you're just planting a tree and you put some water in there and it takes a long time for it to drain out. That's why, because you have those little bricks that are kind of laying together and keeping all that water from draining very quickly. So it's kind of interrelated with soil fertility and quality. I mean, we always talk about, oh, you should amend your soil and put some more organic matter in it, and that's to help the tree roots or the plant roots move through there a little bit easier. It also helps the ability to hold water, as I mentioned, and those little pores for air movement through there. So amending it so that you have a good composition is probably the best thing to do. We'll talk a little bit about that. All right, so how do you determine that? Well, that's a good question. You can totally do it at home. You don't need to bring a sample in and go, hey, folks at Extension, tell me what I got. So you can go get a handful, essentially, of soil, and you get a glass jar and some water. Very simple. And you put that in there and you kind of mix it up and then just let it settle out. And this is an example here. So you can see in this particular sample, it's got a lot of sand in it. So you see that bottom margin, probably about 1.5 inches. That's all sand. And then you've got silt, which is not quite as fine as clay, but still fairly fine. You've got another, roughly 3/4 of an inch, and then clay up at the very top. So the jar test, which is what this is called, you can, go find that online. It's pretty easy to find. You put all of your little information in there, and then you can figure out the percentage that you have. So again, we'll look at a soil pyramid here in a second, but really ideally to me, 33%, 33%, 33%. That's a good mixture. So 33% sand, 33% clay, 33% silt. Mixed together is going to form a really good soil that a tree can put their roots in, and water will retain or will, keep water in there, and it's good for growing things. So here's the soil, the textural triangle, as I mentioned. So after you determine the percentage of what you have in that jar test, this is where you go to find out how good of a soil it is. Maybe you already know, but I just plotted that 60% silt, 25% clay, and 15% sand here. So you can see that all intersects over here in that silty clay loam. Okay, so silty clay loam, it's not bad by any stretch of the means. But again, like I said, the ideal is probably going to be somewhere over there in the corner, sandy clay loam. Because you want something that's going to drain fairly well, that's going to have small enough clay particles to hold water, and still have that silt, which is going to have more nutrients and things in it. Here's another way of telling soil texture. If you don't want to go through all that trouble, you can do the ribbon test. So go out, collect the top 4 to 6 inches, get a handful of soil. So you basically would, if you're going to do your lawn or a garden, let's just say you want to do your garden, take your shovel out there, go down, get a nice shovel full from that top 4 to 6 inches, put it in a bowl, and you're going to wet that soil until it forms a ball. You're going to knead that up, pretend like you're going to make a clay pot from art class back in kindergarten, and you're going to make a ribbon. And then you're going to measure that ribbon length. So if you're doing this and it starts to break off and fall apart, that's the end of your ribbon. And you're going to measure it. So you can see here are samples from clay. So obviously clay, what are you using to make that clay pot? Clay. Clay loam. So that's a silty type material with clay. That's not quite as long, but it's still long. Loamy soils, that's going to be kind of a sandy type soil that you get in forest litter. it's kind of, I call it duff. And that, of course, is not going to be near as long as the clay loam or the clay. Then you have sandy loam, that's got a lot of sand in it. So bigger particles, not going to form a really good long rope. And then loamy sand, the shortest of all of them. So that kind of tells you that's the quick and dirty way to do it if you don't want to wait for your sample to settle out. And here you can kind of see gritty, smooth, all of that stuff, the ribbon length, and does it feel gritty? So this is just a kind of an easy little infographic to tell what you have. So why is pore space important? Why is it important? Well, obviously for oxygen, because your plant roots need something, right? So that's also going to be your water holding capacity. So as I mentioned before, sand is the biggest particle of them all. This is kind of a representation of what these different particles will look like. So it's going to have the highest porosity, meaning rain is just going to filter down through really quick. It's not going to hold water very well. So you have to make sure that if you have a sandy soil, you have an area in your yard that has sand, a lot of sand, you either have to amend it with some organic matter that's going to help hold that moisture in, or you have to water it more. Silt, that's kind of a medium porosity, meaning it holds water better than sand, but not as good as clay. And then, of course, clay has the lowest porosity and the highest water holding capacity because if you have a lot of those little clay particles, they're real close together, they can hold a lot of water. Remember, I said it seals the bottom of ponds, certain types of clay. So you have to kind of visualize why it's important to amend that. So, of course, water needs to flow through the soil, and nutrients are going to be transported by water. Nutrients are the minerals that the plants need to survive. And then, of course, roots need air. So you have to have some of those air particles. And you can see there the differences between the sand and the silt and the clay. And you have way more air particle or air pores in between the sand versus the clay. So you have to, sometimes this helps you visualize what you need or what you have versus what you need. So why, again, is important? So a perfect soil is going to have about 50% air and water and then your minerals. And why? Well, if you compact a soil, you're getting rid of a lot of that, those air pockets. And of course, that's going to pose a problem for the root systems of the plant. So for instance, you have to be careful if you're out there walking through your garden all the time and you compact that row where you're continuously walking, roots that you plant there maybe next year in that row are going to have a harder time growing through that area if you don't amend the soil too much than they would if, say, you had raised beds and you were walking around the raised beds versus just the in-ground beds. So there's going to be a reduced rate of water infiltration and drainage. So sometimes you're going to find those plants maybe a little stunted. They're not growing near as well as the ones right next door where you didn't do all the walking. And here's kind of another visual. So here you can see not compacted versus compacted. And best way to do that, just show you a picture. So here's where somebody tore off across a bean field, and you can see that the plants that are growing in the ruts where the tires went through and compacted that, it could have been a tractor, I don't know. They're not doing quite as well. They're not quite as tall as the other plants because they're having to struggle a little bit more. They don't have as many air pockets in there. It's not holding as much water. It's flowing off. So it's having to work a little harder to live. And so here you can kind of see unrestricted root growth versus kind of a restricted root growth. So we all are kind of taught when we dig a hole to put a plant in, maybe like a tree, that we want to make sure that hole's about, let's say 3 sizes larger than whatever pot it came in. That's kind of a good rule of thumb. Some people like to go and get good compost, like black cow or just some cheap knockoff topsoil from the big box stores or something like that. And they mix that in with that soil, that mineral soil that they dug up, and then they plant that tree back in there. And so what happens is that tree is going to grow right around in that good stuff that you put in there, and it's going to hit the edge of that wall, and it's going to go, oh, I can't grow through that. So it's just going to stay in that one little area. Um, it's not going to go down, it's not going to go out. And so when you have the next drought, you're probably going to lose that plant. And, how do you go about that? Well, you're better off actually going a little further out, dig your hole, but loosen the soil around there. You don't have to amend it. I mean, you can put a tiny little bit in there if you want, just for the help of the plant, but it's better that you loosen that soil up so that that tree can extend roots out into it, that native soil, than it is to put some kind of soilless mixture in there and mix that in, because it's going to love that and it's just not going to grow out into the other mineral soil, and then you end up with a dead plant later. Versus an unrestricted root growth, where you can see here that they've kind of done a little bit of a cross section, and you can see those plants have really grown down in there. That soil has really been worked. It's loosened. It's easy for those roots to grow, and those plants are going to thrive. So again, it's all in the way that those soil particles are arranged together. So just keep thinking about how that clay was just stacked like bricks, versus the sand, which had much larger pores. And basically, how that all kind of works together is they're going to form those, what we call them, aggregates. And that's going to be a mixture of all of those, and how they arrange, how they settle out. That's a good way of putting it. How they form these stable aggregates in this. I don't remember if I have the next slide or not. We'll talk about that. We'll see. But again, you don't need to get too in depth on it. Just know that that's how soils all kind of work themselves out. Oh, good, we did. I whizzed through this earlier. It's been about a year since I've given this. So soil structure, there's 4 types of aggregates. You've got granular, so think sand. You've got prismatic, so columnar, blocky, which are going to be blocks, and platy, which are layers. So think sandstone or limestone, things like that. And why again is it important? Well, obviously, as I've explained, and I like to reinforce, it's how it improves the air and the water relationships. It's going to help with the root penetration. Obviously, you have some selections here. If you have big chunks, it's not very conducive to growing a good root system. Where if you have the first one closer to the left, the good condition, it's a really fine aggregate, and that's easy for roots to grow through. So that's good. You don't want the plant to struggle too much. You want it to find it very easy to grow, so that it can put more energy into producing whatever it is, fruits, vegetables, that kind of stuff. So it'll also reduce erosion and ease of tillage, or what you're doing when you're working around out there in the garden or the farm, and it's going to reduce crusting. So soil structures, adding new organic matter. I love good compost. So if you don't have a compost bin, think about getting one. Erosion and UV radiation. So both of those can reduce organic matter over time. UV radiation can actually break it down. So that's why we encourage you to add more back. Again, the gully washers, if you have a 10 or 12 or 15-year-old Bermuda lawn, it's probably time to go and do some top dressing if you have a hilly yard, because what happens is that water beats down and it carries away that topsoil. So if you started noticing that your lawn is sparse and you don't have a lot of trees around it, it's probably because that topsoil has been washed away, and now those poor little roots, those rhizomes, don't have anything to grow into, because the topsoil is washed away. So you can do something called top dressing, where you get a good compost or a topsoil and you put a 1/2 inch or 3/4 of an inch over the top of it. It'll rain, that soaks down in there, and you've added new topsoil. Those roots are very happy. They can now grow into something. Another rules, these are rules of how to maintain soil structure. Till it when it's moist, but not too wet or dry. Okay, so no mud and not too dry because then it's dusty. You just want it when it's kind of moist. Grow grasses and legumes as cover crops. I'm going to have a webinar coming up on cover crops. Well, low-till methods, actually. So it works for farmers, works for gardeners, too. There's ways of putting nutrients back in the soil, nitrogen-fixing legumes and things like that. There's a lot of good reasons why you want to put some type of a cover crop over there. Mulch, keep that soil protected from the UV radiation and from excessive rainfall so you don't have to worry about runoff. And restrict traffic so that you don't have compaction. So if you can have a dedicated walkway, then all the better. Minimize it down to just one area where you can walk through, and so you're not causing compaction issues anywhere else. So soil structure and color. You can see here in this picture of this field, the very vast differences in the different types of soil. So if you're building a house and you're going to have a septic system, you're going to have a soil scientist come out and they do something called a percolation test. They'll dig a hole, they'll put some water in there, they'll watch it for a while. And the goal there is they want to see which areas of your yard are going to drain well enough that they can put those field lines in for your septic system. So you can see here in this farmer's field that there's a lot of different types of soil out there, just from the different colors, the darker, the lighter, the redder, the sandy color. Those are all different types of soil. Your yard looks virtually the same. You just don't see it because it's underneath all the vegetation. So you can see here down at the bottom, there's some different looks to that. Generally speaking, if you have a red, that's going to be a non-oxidated type of clay. So a lot of our red soil, it's iron based, and that means it's not really been exposed to water. But if you have some gray soils like you see here, that's a reduced soil. That means it's been in a wetland or it's had a lot more water associated with it. So it might be in a low area or something like that. If you have browner soils, that's going to be more organic matter, or blacker soils, that kind of thing. Here's some types of erosion. So you've got bare soil, obviously exposed tree roots. You've got muddy runoff. We see that a lot in a lot of the rivers and streams around here, especially with all the building that's going on. They're supposed to keep all of that silt and sediment on the land. They're not supposed to let that off. So if you see that, it's not the don't ask, don't tell. Tell, because they're supposed to, by law, keep that on their build site. And if they're not doing that, they need to have code come out and get that fixed. So you'll see silt dams where maybe you've got some type of silt fencing and it's butted up against that silt fencing. It's doing its job, but it's probably going to overtop. You'll see rills, which are basically just little trickle marks down a hillside. A soil pillar where something's laying on top and then it's eroded underneath. You've got reduced organic matter. So you've got all that good topsoil has flown away. So think the Mississippi Delta. So that is very rich down there because all the good stuff flowed away. You see sediment fans, same thing, soil buildup along fences on a low area. You can see a very thin topsoil. Again, we don't have a lot of topsoil here, so you got to really take care of what you have. Cracks along a slope and tunnels, things like that. Water will find a way, and it may find its way underground first. So just know that. Wind and water, those are going to be your major causes of erosion here. More prevalent here than out west. And soil erosion, here's basically some of the stuff that I talked about. I'm going to speed up a little bit here. But this is what causes a lack of fertility. Importance of organic matter, again, that's going to hold all that water and the good stuff in there. So you definitely want that. Too much sand, add in some organic matter, grow some cover crops. These are some things you can do. Too little pore space, if you got a lot of clay, till that soil up, loosen it up, add some organic matter, grow some cover crops. A lot of people like the radish method. They grow radishes in the soil and they just leave them. They don't harvest them. They rot in there and they add nutrients to the soil and they loosen it up as they're growing. Too much clay, add organic matter, minimize the soil compaction and grow some cover crops like the radishes. Nutrients, most of you probably already know this, but water, oxygen, carbon dioxide, the primaries, the ones you see on the fertilizer bags, nitrogen, potassium, phosphorus, and potassium, NPK. Secondary nutrients, those are going to be the secondary micronutrients, are the ones plants need not quite as much as the primaries, but more so than the micro. Calcium, magnesium, sulfur, and then micronutrients, boron, zinc, iron, copper, manganese. Magnesium shows up there twice. It should be manganese, molybdenum, and chloride. So what do those numbers mean? General purpose fertilizer. This is a 20-10-20. So 20% nitrogen by dry weight, and that's for shoots or the green stuff. 10% phosphorus for the roots, and 20% potassium for the fruits. So if you have a nut tree, if you have strawberries, if you have blueberries, they're probably heavy potassium feeders. So get your soil tested because they probably need additional potassium. And then, just as an aside, the other 50% are just inert ingredients, just carriers. So this is just, I'm not going to go into the symptoms of nutrient deficiency, but this is just an infographic. Again, if you want the slides, the slide deck, just for your reference, I'm happy to provide that. And again, same thing here. You can get this deficiency chart for micronutrients. They show up in the leaves, folks. So if you know what you're looking at, like you have a quick reference like this, a lot of times you can figure out pretty quick what you're deficient in. So sometimes people just want a complete fertilizer with your micro and your macronutrients, and you just chunk it out there. And that's fine. Sometimes people want to do organics, which is a little more difficult. You have to know what you're dealing with. Here, we're going to chug through this. Nitrogen, it's going to give you those yellow leaves. That is called chlorotic or chlorosis. And you're going to see maybe a little reddish or reddish brown. Phosphorus deficiencies. So leaf tips, they're going to look a little burnt red, and they're going to have older and darker leaves. Potassium, not red, but yellow, chlorosis. So those older leaves may be kind of wilted, look a little scorched. The interveinal, you might have some yellow in those veins. Iron, you've got a yellow or with greenish veins. And again, this, I am happy to provide the slide deck. We're kind of moving through fast because I'm pretty much out of time. I like to talk if you haven't figured that out. Calcium, blossom end rot. And then here's pH. Long story short, oops. It's important to know 7 is neutral. Most plants are going to be happy 6.2 to 6.8. Some like blueberries, azaleas, that kind of thing, prefer a little bit more acidic, so a little further to the left. But generally speaking, it's going to be 6.2 to 6.8. When you, it's a logarithmic scale. So if you have to do any corrections, you have to do it slowly because you can shock your plant and kill it. And it takes a while for a pH to change in that soil column. So it's important to do it very slowly over time. We do recommend you do a soil test in the fall. That way you know what's going on and you have enough time to correct your soil if you need to. So it's going to influence the ability of that plant and how to absorb nutrients. You can kind of see here the differences. There's a lot of different nutrients, like I told you, that plants need, and that pH can determine how that plant absorbs them. So at a 7.1, pretty neutral, all the way down to a much more acidic 5.3, you can see those plants can't absorb some of those really important nutrients because of that pH. It changes that bioavailability. And you can see that with the root system too. And here, that yellow box shows you the easiest, that's why the plants like it so much. The way like nitrogen is, you see the widest area, that means that it's most bioavailable in that particular area. So plants need the most nitrogen, the most phosphorus, the most potassium. And then the next group down, so basically in need, it moves further down. But you can see it needs the most nitrogen, phosphorus, and potassium. And so that's the area, that's the pH the plants like the most of. Then you have sulfur, calcium, and magnesium, and then iron, manganese, boron. So they're, more available on the lower end of that pH scale. And then molybdenum, which plants need, but not a lot of. It's obviously more bioavailable in a much more alkaline environment, but plants don't need a lot of it. So it's usable in the amounts that they have at that pH. So ones they prefer: blueberries, potatoes, azaleas, all acid loving, so 5 to 5.5. Lawn grasses, flowers, perennials, spring flowering bulbs, mostly in that 6 range. Corn, tomatoes, onions, cabbage, most of those summer crops, there's your 6 to 6.5 or 6.8. And though you don't really need to, if you have to lower it, you can put sulfur, which is going to make it more acidic. If you need to increase it or make it more alkaline, you would add lime. We have to usually add lime. The soils around here tend to be about 5 to 5.5. Great if you're a blueberry, not so great if you're a tomato. So when you do a soil test, they'll come back with recommendations. If your pH is too low, they may suggest that you increase the lime buffering capacity or add lime to your soils to make it more conducive for growing your vegetables. All right, collecting a sample. For those of you that don't care about collecting a sample, if you need to leave, you can go ahead and leave. We're moving into the how to collect a sample and how to read it now. So if you were just here for the science of it, that's fine. If you can hang out, we'll zoom through this, and then if anybody has any questions. So how often and when? Anytime. But if, as I mentioned, if you have to adjust that pH, it's going to take 3 to 6 months. So try to plan ahead. So if you're going to plant in the spring for your summer garden, try to sample it in the fall. And lawns and ornamentals, check it every 2 to 3 years. You want, to kind of make sure that the pH isn't too off. Sometimes people think they're doing their lawn a favor and they're just tossing some lime out there. And honestly, they're actually doing themselves a disfavor, because before too long, it's outside of that range that the grass likes and it starts looking bad. And then you have to think about adding sulfur. I have stories, but I'll have to save some of those for now. Gardens, check it every couple years, and fall again is the best time. So how do you do that? Well, you're going to take a random sample. This is how you kind of break it up. So if you have a wooded area out back with a woodland garden, that's an area. You have a vegetable garden, that's an area. You got grass, front yard, backyard, a low-lying area, that's going to be its own area. So in there, you're going to go with your shovel and a clean bucket, and you're going to go 2 to 4 inches down, and you're going to take a bucket full of, or a shovel full of soil, and put it in that bucket in that area. So that wooded area, the vegetable garden, mix that up. And then you're going to take about 2 cups of that, put it in a Ziploc bag. That's your randomized sample. Okay. So we don't just take from one spot. You're going to take from multiple spots within whatever you're growing. So some things to note: lawns, pastures, 4 inches deep. Gardens and crops, 6 inches deep or as deep as you till. For trees, bushes, like blueberries or things like that, go out to the drip line or where the root system is, where the root system is going to absorb. So that's important. And then always use clean tools. So wash that bucket out, wash that or hose that shovel down. You want it clean, okay? So you're gonna, in a lawn, you're gonna clean out that thatch. You're just gonna push that grass aside because you don't want the grass in there. And then you're gonna, this is a trowel, but you can use a shovel too. So take a slice from that clean area, take it down, and put it in a bucket. You're gonna do that a bunch of times, 6 times, 7 times, depending on the size of the area, and mix it thoroughly. Why? Because it's a representative sample of where you're trying to grow that particular whatever. So you're going to fill that bag up to that line. So remember, I said you're going to dump all that soil, at least 2 cups, into a Ziploc bag. And then you're going to come down to our office and you're going to grab one of these little sample bags and you're going to fill it up to that yellow line. Why? Because if you don't, the soil lab gets really mad at us. They don't have enough soil to complete the test. So just fill that baby up. I don't want to have to call you and go, you got to bring more soil down. So make sure you fill it out. You got to put your name, address, city, zip code, and then you see that little thing called a crop code. Well, that is what you're testing for. So if you have a set of blueberry bushes, there is a code for blueberries. If you're checking Bermuda lawns, there's a couple codes for Bermuda lawns. If you've got like azaleas, there's a code for azalea. There's a code for just about everything. If you have multiple things, that's fine. They have you put up to 5 codes per bag. And what that means is they're going to give you recommendations on that report for that particular code. So if you want to put blueberries someplace, then you're going to put the crop for blueberries on there so that when you send that sample in, and you may just have it as a field now or something, you want to know what you need to do for blueberries. So keep in mind that if it's a new area, put whatever it is that you're going to plant there as your crop. And it takes 7 to 10 days. As we collect more and more samples in the spring, which is a popular time, sometimes we'll send them out twice a week because we get so many. But in the fall, kind of depends, usually once a week. All right, how do we interpret it? So that information is going to help you make some decisions on how to fertilize it. Do you have to add lime? That kind of stuff. And we get a lot of calls from people that just really have a hard time reading that test. It's pretty straightforward, but sometimes if you're not very scientifically inclined, you may stare cross-eyed at it and you still don't know what in the world it's trying to tell you. So the samples all go to the Feed and Environmental Lab or the Soil and Water Lab in Athens. So you can drive it there if you want to, and you can get them either through the mail or email. So here's what a report looks like. You have the sample ID. That's going to be your name and your address, the name of your sample. You can call it whatever you want. You can call it Uncle Bob's pasture if you want to, or it can just be front yard or backyard, whatever. Your results, that's going to show you, and we don't test for nitrogen, that's highly variable, but we do for phosphorus, potassium, and then the other secondary macronutrients, and then also pH. pH, again, remember, determines how bioavailable those nutrients are. And then the recommendations. So that those crop codes that I was telling you about, the crop code is what the lab uses to put that information there. So if you said you were testing for blueberries or Bermuda grass, they're going to give you recommendations based on those crop codes for those particular crops. And this little handy thing, this is your fertilizer calculator. So there's so many different types of fertilizer out there. You may already have some in your garage. Maybe you don't want to go out and buy the 10-5-8 that they recommended, but you have 12-5 in your garage. You can go here to this little handy dandy website and you can put in what you have, and it will calculate out for you the difference in how much you need to add based on what you have versus what they told you you needed to get. Did that make sense? So just save money, use what you have, and use the fertilizer calculator here. So if you have the report, the digital report, it's an Adobe PDF file. You just click on it and it'll take you right to the website. So here's your sample ID. The crop in this case is the centipede lawn. So, but it could be blueberries, it could be azaleas, it could be whatever. The lab information, that's how they code that particular sample. So it's sample number 8705, and then the date that it was completed, and then county information. So not everybody brings it to us first. You can certainly take it to the lab if you would like. Okay. You don't need to come see us if you know, feel like driving out to Athens and you want to do that. They have a business office and you can drop your samples off there and pay there. Everything goes into a big system and we can look at all of it. So you may not understand how to read it, and that's fine. You just give us a call. We'll look you up in the system and pull you up, and I'll look at it on my computer and I will read it off and interpret it for you. So pretty handy. Here you can see primary nutrients. So this bar, the yellow line that you see, that is above that, you have too much. Below that, you don't have enough. So in this case, on this particular one, there's plenty of phosphorus. You don't have to adjust it. Potassium's low. You're probably going to have to add some. Calcium's fine, magnesium is fine, and zinc is fine. And then if you flip over to lime, you can see your pH is 6.1. I'm going to take a stab. They're probably growing blueberries or something, because in this case, you want a lower pH, but lime isn't needed at this point. It's fine. They're probably going to recommend you don't do anything to it. Now, if it was off the scale, like 8 or 10, they're probably going to recommend that you adjust it down, because most plants can't grow up in that 8 or 10. Again, pH levels are important. You want to keep it neutral or below. Optimal range, again, 5.4 to 6.8. The lower the pH is probably blueberries or azaleas or rhododendrons or gardenias, something that's acid loving. Lime buffer capacity. This can hurt your head if you think about it too much, but because our soils are pretty acidic, pH, you have to add a lot of whatever it is, lime or sulfur, to get a change. A limestone-based soil, you don't have to add as much because of the buffering capacity of the soil. So all you really need to remember is you've got to add more of whatever you're using to adjust your pH in our soils than you would in a limestone-based soil. That's basically it. Don't worry so much about the number. If you need help, we can help you interpret it. Don't go cross-eyed at this. This is just the lime buffering capacity. It basically gives you a good calculation of how much you need to add if you have a soil pH of whatever on the left and your lime buffering capacity. So you might need to add a lot more if you really have a high lime buffering capacity. But again, don't go cross-eyed on it. Okay, nitrogen. Again, I mentioned we don't test for that. So because it's variable, it leaches out of soils readily, and especially sandy soils. So you do need to add something back in that has nitrogen, because all the green stuff that grows on plants needs it. Here in the recommendations section, the lab is going to tell you how many pounds of fertilizer per acre you need to add. In this case, limestone, no recommendations there. Nitrogen, see comments. Again, they don't test for that. Phosphate, and 50 pounds an acre. Potash, 40 pounds an acre, that kind of stuff. So you can see application rates, nutrient rates, secondary micronutrients, that kind of thing. This is what it looks like. So no limestone needed, recommended pH, and then it'll give you some more in-depth instructions. This is for grass. And recommended pH, sulfur, adding sulfur, that kind of stuff. You can see these are vegetables, heavy feeders like broccoli, cabbage, that kind of stuff. Home vegetable gardens, borax, here's an organic solution. So they're always tweaking those things. So you're going to find that there are some organic solutions there. How do we keep them healthy? I'm almost done, I swear. Add organic matter. Till the soil again when it's not too wet or not too dry. Grow grasses, legumes for nitrogen fixing as cover crops and to keep those roots in the ground. Keep that soil protected. Use mulch. That's a good one. It's great. Goes right back as nutrients into the soil. And grow a selection of plants. Don't stick with the same ones. Do some crop rotation because you'll get different microorganisms that are growing around different types of plants. Avoid compaction if you can. That's always best. Yay, we're done. Oh, goodness. So there's always so much to talk about. Um, oops, there. All right. So if you are interested, here is my email address, phone number, and we have lots of other classes that are coming up. You can do the top QR code will take you to our website, UGA Extension Gwinnett, on events and classes, and you can see the other stuff that we have coming up in the next 3 months. And then this is again being recorded. So you can go to my YouTube channel, Metro Master Gardener. That's where everything gets put when I'm done with it. So this will show up there on the Metro Master Gardener YouTube channel. I don't know, there's like 75 or some odd number there that you can watch. All of them count for CE. So if you need CE, feel free to peruse that, or if you need to fall asleep and it's 3 a.m. and you can't fall asleep, watch something else. All right, so I'm gonna look here real quick. So it's okay if you had to go. I know folks' time is of the essence. Sending slides. So folks, if you want the slides, I'm not going to keep your email address. Write down my email address and email me. So you see it right there. Take a screenshot, take your phone out, take a picture, and email me and tell me that you want the slide deck for the soils program. All right, let's see. Yes, just again, that's great. I'm happy to share the slides. Just make sure that you um, email me. Okay. An email. Email me, take the picture. I'm glad that you want them though. There's lots of good reference material in here. Oh, I'm flattered. Everybody wants the slides. Okay. And so no questions about soils or anything I taught? Yes, it's all ratios. So the question was, most of us don't have acres of property. So when adding amendments, we should make a ratio. That fertilizer calculator, that does ratios. It will tell you exactly what you need. But yes, it's all ratios. So you can use a ratio calculator. I love AI for this. You can tell AI what to do and it'll do it for you. But so will the fertilizer calculator. So lots of great, if you're not great at mathing, that is absolutely fine. There are lots of resources out there that will calculate it all for you. Okay. Does anybody else have any questions about soils in general or anything? Oops. Malic. Malic 1 test appropriate for moderately to heavily amended natives. Yeah, that's fine. The only one that it is not appropriate for is if you have a soilless mixture. So if you go to the big box store and you buy those big bags that say raised bed soil, that is a soilless mixture. Okay. It's not native soil. It's just a mixture of compost and other stuff that they put together. It's perfectly fine for your raised beds. It's got the nutrients that are necessary. Just know that periodically you need to add in more nutrients because it is not native soil. You're going to exhaust the nutrients that are in there. But the particular test that is mentioned here, the Malic 1, is best used on native mineral soils. So if you are in ground and growing in ground, that's the type of test that you want. But there is a nursery test that if you're growing in raised bed soil, if it's the first year, you probably don't need to do anything. But if it's year 2, 3, 4, and you haven't done anything, then there is a nursery soil test that's meant to be used. It's not a Malic 1. So it's that S1 soil test that you saw the results for. It's a different one. So just call us. We'll walk you through it. Is the topsoil native? So the bags that you get at the big box stores that say topsoil are not topsoil. It's composted pine bark. So it's not actual mineral soil. It's just composted pine bark. Pine bark. It's cheap. It's like 98 cents a bag. It's a great additive if you have mineral soil and you're just trying to improve the organic content in your mineral soil, but it is not a one-stop shop for a raised bed. You need something that has other stuff in it. Otherwise, your plants will look absolutely horrible and you won't get anything out of them because there's not enough nutrients in there. It literally is just organic matter with some very minute nutrients. Okay. How soon will you post the slides to the recording? So the recording might go up tomorrow. I have to usually edit it a little bit once I put it up there, and then I have to wait for it to buffer and load. So if depends on how busy I am. I'll probably get it uploaded, but I may have to come back later and edit it. So, where do you recommend getting good mulch? It depends on how much you need. If you're looking at just a couple of raised beds, then I recommend just going to the store and getting Black Cow. It's in a yellow bag. It's manure and it's a good organic addition to your raised beds. But if you have a rather large area, then you can go someplace like Buck Jones Nursery or Pike Nurseries where you can get they'll have a front end loader and put it in the back of your truck. So that's an option if you have a bigger area. What I do want to stress is that if you have a horse farm down the road and they have offered their manure to you for free, please be careful because a lot of the pesticides that they use now, herbicides, pesticides, just the main label, the biggest one that is used right now is called Grazon, and that is, I believe it's pichlorum, but it's UV stable, and a lot of these herbicides that are used break down by microbes and also UV radiation. But Grazon does not. So it actually is biostable or it's persistent in the environment for up to 2.5 years. And while it's not harmful to humans, that's the reason it's used so heavily is because there's no withholding period. You can leave your animals out there after you spray. It is really bad for tomatoes and peppers. So many people, I think people are more aware now, but people were getting manure and even from sources that should have been safe, and they mix it in with their raised beds or their in-ground gardens, and the plants look great for a month or two, and then all of a sudden they start curling and they look really bad on top. And that's because that particular herbicide, the Solanaceae family, is super sensitive to it in the parts per billion. So it doesn't take a whole lot it's a growth regulator. So basically what it's doing is it's still in the poop, and then the plant uptakes that and has the chemical that hasn't broken down yet. And it's very sensitive to that chemical. And so its growth is regulated. So it has herbicide damage and you don't get any crops. You just have this poor, sad looking tomato that you can't do anything with. And then you have a sterile field where you can't plant tomatoes, you can't plant peppers, you can't plant, those are the two that are probably the most sensitive to it. But you really can't plant those for the next 2 years because they're too sensitive to it. So you wouldn't get, crops out of them. So just be careful if you're getting manure from a horse farm or a cattle farm or something like that. If you have a source, ask them what they spray. It's very important. And if you have questions about the persistence in the environment, you can always reach out to us and we'll be happy to answer. Any other questions? No? No? Okay, I'm going to stop sharing. Okay. Well, a bunch of you hung around, so I appreciate you tuning in. I hope everybody got some good information and learned a little bit about the geology of Georgia soils, and how to take a soil sample, what the soil sample means, how to kind of read that, how the nutrients and all that tie in. And if you have any other questions, you can definitely feel free to reach out to me. But again, if you want the slides, I hope you took a picture of the email address, or if you know how to get a hold of me, email me. You can get that off the website to our website. And I am happy to send you a copy of the slide deck. I just don't typically go in and pull all the email addresses off the chat. So thank you all again. I appreciate you coming. Hopefully you'll come for some more of my webinars. I should have a bunch on vegetables and gardening and some other stuff since we're moving into that season. So please come. I love doing these, and I hope you got something out of it. So we'll see you all later. Thank you.